Hello and welcome to another one of these ADD videos. Today we're going to look at the alternating series test. And as the name implies, we have a component of this series that will alternate. Whether it's a -1 to some power of n or a sine or a cosine term, both of those make it alternate. If you remember, sine and cosine oscillate between 1 and -1. So what are the steps? Once you recognize it as an alternating series, you drop the alternating portion right away and just look at the a sub n. Take the limit of that a sub n as it approaches infinity, the n approaches infinity. If it equals 0, you've met the first condition of the alternating series test. If it does not equal 0, you write down diverges by nth term test. If you remember, we did this as the first test for the series. And if the limit does not equal 0 of your sequence, then it diverges. All right? Nothing to do with alternating series, even though you started out with an alternating series test. Okay? So let's say that the second step did pass, the limit equaled 0. Then you'd have to prove it was decreasing. You could either do it by taking the derivative of the sequence and proving that it's less than 0 for all n element of the natural numbers, or you could do a proof. If you forgot how to do these proofs and all that, see the sequence videos, the example videos, and the concept video for a refresher. All right. After you do that, you're going to rewrite the series without the alternating part and do a different test, something that's not alternating series. What happens is sometimes you'll meet both 2 and 3. It'll be a decreasing series and the limit will equal 0. However, if we drop the alternating part and do a totally different test, whatever test you choose, a sub n alone might diverge. And in that scenario, that's called a conditional convergence or conditionally convergent, however you want to say it. But if it passes that other test, then it's absolutely convergent. Okay? Under all conditions, it converges. Whereas the other one, it only converged under the condition of the alternating series test. Okay, so again, recap real quick. What are we going to do? Drop the alternating part, take the limit. If it equals 0, we're good. If it's decreasing, we're good. Do a different test using a completely different test besides alternating series test. If that converges, then it's absolutely convergent. If it doesn't, it's conditionally convergent. Okay, I hope that's clarified the steps behind the alternating series test. Make sure you tune in to the example videos when I'm going to take out these two examples and hopefully further clarify things for you. So practice, practice, practice. That's the most important part of this game. And thank you and have a nice day.